Hi my dear students, welcome back to the class. So far we were discussing about relations and functions. We discussed what is a relation, and then we discussed and defined a function. We defined certain kinds of functions like identity function, modulus function, signum function, greatest integer function, etc. And then also we defined about the algebra of functions, isn't it? In this class we are going to solve exercise 2.3, which connects all the questions related to functions as well as to relations. Okay, always remember that every function is a relation. Basically, functions are relation. So, without any further intro, we shall move on to the first question. The first question of exercise 2.3 is that which of the following relations are functions? Give reasons. If it is a function, find the domain and range. So we are asked to find the functions from these three relations. Of course, these three are relations because these are ordered pairs, and so these are subsets of A cross B. Hence, we should find whether these subsets are functions or not. Also, if it is a function, we are asked to find the domain and range. So that's the question. So first one, here we can see that. Always remember that in order to check whether a relation is a function or not, just observe each ordered pair. Why should we observe each ordered pair? Because if there is no two distinct ordered pair have the same first element, then it will be a function. We know that how to check whether it is a function or not. So if no two ordered pairs have the same first element, then it will be definitely a function. So we can observe that there is no two distinct ordered pairs having the same first element, isn't it? So definitely this is a function. So this is a function. Therefore, domain, we know that domain is the set of all first elements in the relation. So 2, 5, 8, 11, 14, 17 is the required domain. Now we shall find what is the range. We know that range means the set of all second elements. Here we have only one second element, which is singleton 1. So this is the domain and range of this function. Now coming on to the second one, we are given with a certain ordered pairs. Also here also we can use the same idea of function. Always observe that in order to check or in order to test whether a given relation is a function or not, just do this. Just observe these ordered pairs very well. Then if we can see there is no two distinct ordered pairs having the same first element, this will definitely a function. Here you can easily observe that there is no two distinct ordered pairs having the same first element. Therefore, it is a function, and the domain, it is equal to the set of all first elements. 2, 4, 6, 8, 10, 12 and 14 is the domain of the function. And coming on to the range, range is the set of all second elements, which are they 1, 2, 3, 4, 5, 6 and 7 is the range of this function. Coming on to the last one, here we are given with three ordered pairs. It is easily observable that these two distinct ordered pairs have the same first element, which is 1. Therefore, it is not a function. So this is the answer for the first question of exercise 2.3. Now we shall move on to the next one. Now we shall move on to the second question. The question is that find the domain and range of the following functions. So we are asked to find the domain as well as the range of the two functions given by f of x is equal to minus of mod x and f of x is equal to square root of 9 minus x square, isn't it? So first of all, we are going to evaluate the domain and range of this function. Let f of x is equal to minus of mod x. Now we know that the function mod x is given by, what is the definition of the function mod x? It is x when x is greater than or equal to 0 and minus x when x less than 0, isn't it? So minus of mod x becomes, see, we have to multiply mod x with the negative sign. So it will become minus x if x greater than or equal to 0. Now minus into minus, plus x when x less than 0. So this is the functional value of minus of mod x. Now observe that whenever x is positive, the functional value become minus x. For example, if x is 2, the functional value will be minus 2, isn't it? So whatever be the positive value of x, if whenever x is positive or a positive real number, the functional value will be negative of that. For example, if function x is 4.3, the functional value is minus 4.3, isn't it? Let it be there. Similarly, if x is negative, the functional value is x itself, which means that if x is less than 0, which means if x is minus 2, the functional value will be minus 2 itself. If x is minus 3, the functional value will be minus 3 itself, which means that the domain of that function, domain is equal to, what is the domain? We can put any real number as the functional value. It can be positive or it can be negative. So domain is the set of real numbers, whereas the range, what is the range? Whatever be the value of x, even if it is positive or even if it is negative, the functional value will always be negative. If it is 2, it is minus 2. If it is minus 2, then it is minus 2 itself, isn't it? So range is all negative real numbers. So this is the domain and range of the first function. Now we shall move on to the second one. F of x is equal to square root of 9 minus x square. See, here the square root of 9 minus x square is given. So we know that square root is defined for only positive numbers, isn't it? We cannot find square root of minus 25. We cannot find square root of minus 35, etc. So in reality, or we cannot find a real solution for square root of a negative number, isn't it? Therefore, this 9 minus x square must be a positive number. Therefore, 9 minus x square must be greater than or equal to 0, which means 9 must be greater than or equal to x square, which means x square must be less than or equal to 9, which means x is less than or equal to 3, or my x is greater than or equal to minus 3, which means minus 3 less than or equal to x less than or equal to 3. So the only possible input values for x is minus 3, in between minus 3 and 3. Therefore, the domain of f of x is nothing but set of all x such that minus 3 less than or equal to x less than or equal to 3, isn't it? That means closed interval minus 3, 3 is the domain of this f of x. Now we shall discuss about the range. See, if we put the least value minus 3, then the function will be 9 minus 3 square is again 9. So 9 minus 9 will be 0. So if we put the least value, the functional value will be 0, which means that we can find f of minus 3 is 0. Similarly, f of 3 is again 0. And f of 0, what is f of 0? If we put 0 here, it will be 9 minus 0, it is square root of 9, it is equal to 3. Which means that the least possible value of range is 0 and the maximum possible value of range is 3. Therefore, range is equal to closed interval 0, 3, or range is equal to set of all x such that 0 less than or equal to x less than 3. So this is the range and this is the domain of this given function. Coming on to the third question, the question is that a function is defined by f of x is equal to 2x minus 5. We have to write down the values of f of 0, f of 7, f of minus 3. It's very simple, you know that. See, in order to find f of 0, we have to put 0 instead of x here. So we can find f of 0 as 2 into 0 minus 5. It is equal to 2 into 0, 0 minus 5, it is equal to minus 5. So that is f of 0. Coming on to the second one, f of 7. We have to put 7 instead of x here. So it will become 2 into 7 minus 5. It is equal to 14 minus 5. It is equal to 9. So this is f of 7. Again, f of minus 3. we have to put minus 3 instead of x here. It will become 2 into minus 3 minus 5. It is equal to minus 6 minus 5. It is equal to minus 11. So this is f of minus 3. So we get f of 0, f of 7 and f of minus 3. Coming on to the fourth question, the question is that a function t which maps temperature in degrees Celsius to temperature in Fahrenheit is defined by, we are given with a function t of c is equal to 9c by 5 plus 32. Note that it is of the form f of x, where c stands instead of the variable x, and instead of denoting the function by f, we denoted it by t. That's it. So we get the function like this. Now we are asked to find these values. It's very easy. Just like the previous example, t of 0 is equal to 9 into 0 by 5 plus 32. It is equal to 9 into 0 is 0 and it is equal to 32. Similarly, we can easily find t of 28. What is it? 9 into 28 by 5 plus 32. It can be easily found out. Again, we are asked to find t of minus 10. It is equal to 9 into minus 10 divided by 5 plus 32. 32. It is also can be easily evaluated. Now, a question which is different from all these questions is fourth one. We have to find the value of c when we are given with t of c. Here, what happened here is we are given with the value of c and we are find out t of c. Here we are given with t of c itself and we are to find out c. So t of c is equal to 212, which means that 9 into c by 5 plus 32 is equal to 212, which means that 9 into c by 5 is equal to 212 minus 32. It is equal to 180. So 9c is equal to 5 into 180. Therefore, c is equal to 5 into 180 divided by 9, which is equal to 5 into 90 into 2 divided by 9, which is equal to 100. So this is the value of c when t of c is equal to 212. Now we shall come into the fifth question. The question is that find the range of each of the following functions. So we have to find the range of the functions. F of x is equal to 2 minus 3x, x element of r, x greater than 0. F of x is equal to x square plus 2, x element of r, and f of x is equal to x, x element of r. So these are the functions we are given with, so that we have to find the range. Okay. Now, let me ask you a question. What is the domain of these functions? Yes, it is clear that the domain of the first function is this, the domain of the second function is this, and the domain of the third function is the set of real numbers. Why? Because the domain means the set of all input values. We are given with the set of all possible input values are this, x. So this is the domain. So we have to find the range. Coming on to the first one. So first one, f of x is equal to 2 minus 3x. We are given that x greater than 0, isn't it? So that 3x will be again greater than 0. So minus 3x will be less than 0. So 2 minus 3x will be less than 2 minus 0. Which means that 2 minus 3x is strictly less than 2. Which means that 2 minus 3x is nothing but the functional value, which is the range, which is less than 2. Therefore, range is equal to set of all x such that minus infinity less than x less than 2. Why minus infinity? Because there are infinitely many values which are less than 2. We know the number line. If it is 2, we have 1 here, we have 0 here, we have minus 1 here, and it goes on like this. So all numbers to the left is less than 2. So these numbers will goes to minus infinity. Therefore, range can be also be defined as open interval minus infinity 2. So this is the range of the first function. Now we shall do the second one. F of x is equal to x square plus 2 x element of r. Whatever be the functional value or whatever be the input value x, whether it is negative or positive, we know that x square will be greater than 0. Therefore, 2 plus x square will be greater than 2 plus 0, which is 2. Therefore, the range, see 2 plus x square is actually the range, the functional value, which will be greater than, x square will be greater than or equal to 0. See, since 0 can have square is 0. So 2 plus x square will be greater than or equal to 2. Therefore, range is equal to set of all x such that 2 greater than or equal to 2 less than or equal to x less than or equal to infinity, since there is infinitely many values to the right side of 2, isn't it? Since 2 plus x square is greater than or equal to 2, 2 is the least possible value of the range. So 2 less than or equal to x less than or equal to infinity, or range can be again defined as closed interval to infinity. See, here we used closed interval because here we have less than or equal to, or we can use this either. No, it doesn't matter, to infinity. So this is the range of the second function. Coming on to the third function, very simple. If x element of R, then f of x is equal to x. The same is element of R. Therefore, range for the third function is set of all real numbers itself, because input value is element of R. Range is again the same as of the input values, so it will be also element of R. So range is equal to R in the second set. So the third one. So this is the end of this chapter. We have finished all the exercises. So I hope you are very clear with relations and functions. So this is the end, and we can move on to the next chapter in the next class, which is trigonometric functions, a very special kind of function. So till then, wait for the next class. Bye bye.